Hello, TechBusters. Ready to spin in the world of Python loops? Today, we're embarking on an exciting journey into for loops, Python's way of handling tasks that need a bit of repetition. Think of for loops as the DJ of programming, playing your favorite code on repeat until it's time to switch the track. Let's dive in and discover how to put these loops to work. Let's jump right into the world of for loops in Python. In programming, sometimes we need to perform a task repeatedly, like counting from 1 to 10 or going through each item in a list. This is where for loops come into play. They are Python's way of handling these repetitive tasks efficiently. The for loop has a simple syntax, for variable and sequence. Here, variable is a placeholder that takes the value of each item in the sequence, one by one. Think of it as a conveyor belt, where variable picks up each item as it comes along. In this snippet, we have a list of numbers from 1 to 5. Our for loop goes through this list, and in each iteration, it assigns the next number to the variable number and prints it out. It's a bit like counting on your fingers, each finger representing a number from the list. One of the beauties of for loops is their flexibility. They're not just for lists. They can waltz through any sequence. Let's say we have a string, hello. We can loop through each character in this string using a for loop. Here, our loop takes each character in hello and prints it out, one letter at a time. The variable char gets assigned to H, then E, and so on, until the loop has danced its way through the entire string. Now that we've got the hang of the basic for loop, let's see how it becomes a superhero when teamed up with collections. In Python, collections like lists, tuples, and dictionaries are more than just storage. They're treasure troves that for loops help us explore. Let's unlock these treasures. First up, lists, Python's versatile collection. Whether it's a list of names, numbers, or even other lists, for loops can go through each element with ease. It's like having a personal assistant to go through your shopping list, item by item. In this example, our for loop is like a gourmet chef, savoring each fruit in our favorite _fruits list. The loop takes each fruit, first apple, then banana, and so on, and performs the print action with it. Tuples, the immutable cousins of lists, are also great dance partners for loops. Iterating over a tuple is similar to a list, but here the items are fixed, like the notes in a musical scale. Here our for loop is like a musician playing each note in the tuple _of numbers. It neatly picks up each number and presents it, showing the ordered and unchangeable nature of tuples. Let's not forget dictionaries, Python's own key-value storage. Iterating over a dictionary can be done in a few ways, through its keys, values, or both. It's like having a map where you can choose to explore just the landmarks, the routes, or both together. In this snippet, the for loop explores the user_info dictionary. Using the items method, it gets both keys and values like name, Alice, making it a handy tool for accessing dictionary data. Let's shift our focus to a special ally of the for loop, the range function. This nifty function is like the rhythm section in the orchestra of Python loops. It sets the pace and counts the beats for our for loops, allowing us to iterate a set number of times with precision and simplicity. The range function in Python is straightforward yet powerful. At its simplest, you give it a number, and it generates a sequence of numbers for you, starting from 0 and going up to, but not including that number. It's like saying, "Hey Python, count up to 5 for me," and Python responds with 0, 1, 2, 3, 4. In this snippet, we ask our for loop to work with range 5. This tells Python to loop 5 times, with I taking the values 0 through 4, one by one. It's an efficient way to repeat actions a certain number of times. But wait, there's more. The range function can take up to 3 arguments, a start, an end, and a step. When you provide 2 arguments, range starts counting from the first number, up to but not including the second. It's like setting the start and finish lines for a race. Here we told range to start at 1 and stop before 6. So I takes values 1, 2, 3, 4, and 5. This flexibility makes range incredibly useful for controlling the flow of your loops. Need more control? Add a step parameter. This third argument tells range, how much to jump with each iteration. Want to count every other number? Just set the step to 2. It's like hopping through the sequence. See what happened here? We started at 0, went up to 10, but took steps of 2. So I become 0, 2, 4, 6, and 8. It's a great way to iterate over sequences with more control. Having explored the range function, let's take a step further into the world of for loops. Now, we're entering the realm of nested for loops. It's like placing a loop within another loop, a bit like a story within a story. Nested loops are incredibly useful for working with multi-dimensional data, or when you need a loop to run inside another loop. A nested for loop in Python is simply a for loop inside another for loop. The inner loop completes all its iterations for each iteration of the outer loop. Imagine a clock with 2 hands. For every hour, outer loop, there are 60 minutes, inner loop. Here, for each hour, the inner loop counts all 60 minutes. The outer loop gives us the hour, and the inner loop counts through the minutes of that hour. It's a perfect demonstration of how nested loops function. Let's explore a crucial aspect of for loops in Python, the loop control statements. Think of these as the steering wheel and brakes for your loops that give you the power to take charge of the loop's execution, making your loop smarter and more flexible. We'll focus on 2 primary controls today: break and continue. First up, break. This is like an emergency stop button for your loop. When Python encounters a break statement, it immediately exits the loop, regardless of its natural life cycle. It's handy when you need to stop the loop based on a specific condition. In this example, our loop is counting numbers. But as soon as it hits the number 5, break kicks in, and the loop stops. It's a great way to prevent unnecessary iterations once your code has found what it's looking for. Next, we have continue. This is more like a skip track button. When a continue statement is encountered, the loop skips the rest of its current iteration and moves on to the next one. It allows you to bypass parts of the loop under certain conditions. Here our loop runs through numbers 1 to 9, but with the continue statement, it skips every even number. The result? Only the odd numbers get printed. Continue is perfect for when you want to ignore certain items in a sequence. While break and continue can be incredibly useful, it's important to use them wisely. Overusing them can make your loops complex and hard to follow. A good rule of thumb is to use them sparingly and only when they make your code more readable and efficient. Now let's turn our attention to one of Python's most elegant features: comprehensions with for loops. Comprehensions provide a concise way to create lists, dictionaries, or sets based on existing iterables. Imagine creating a masterpiece with just a few brush strokes. That's what comprehensions are all about. Let's start with list comprehensions. They allow you to create a new list by applying an expression to each item in an existing iterable. It's a compact, readable way to transform data. No need for multiple lines of looping and appending. List comprehensions do it all in one. In this example, we take a list of numbers and create a new list of their squares. The expression number ***2 is applied to each item in the original numbers list. The result is a neat, new list of squared numbers. Python also offers dictionary comprehensions, which are ideal for creating dictionaries dynamically. Similar to list comprehensions, they build dictionaries by transforming and filtering data in a single, succinct line. Here we create a dictionary that maps fruit names to their lengths. The len, fruit, expression calculates the length of each fruit in the fruits list, creating a key value pair in the new dictionary. And don't forget set comprehensions. They're similar to lists, but they're used to create sets, collections of unique items. Set comprehensions are great for when you need to eliminate duplicates or when order doesn't matter. This snippet takes a list with duplicates and turns it into a set of unique numbers. Simple, yet effective. Comprehensions are not only about writing less code, they're about writing more readable and efficient code. They streamline tasks that would otherwise require more complex loops, making your Python scripts more Pythonic. There you have it, the magic of for loops in Python. These loops are your reliable friends in the coding world, helping you automate the repetitive so you can focus on the creative. Stay tuned for more loop adventures in our next episode, where we'll unravel while loops. Until then, keep practicing, keep coding, and as always, keep enjoying the journey with TechBuster.